Modbus is a messaging protocol used to establish communication between intelligent devices. Since its development in 1979, it's become the de facto standard for the industrial manufacturing environment. Originally designed for serial communications with Modbus ASCII and Modbus RTU, it was later adapted to utilize Ethernet networks with Modbus TCPIP.
Modbus devices communicate using a master-slave technique in which only one device, the master, can initiate transactions. The slaves respond by supplying the requested data to the master or by taking the action requested in the query. UEI chassis can be easily configured as a Modbus TCPIP slave through a web interface. To start the setup, simply enter the IP address of your UEIModbus chassis, followed by /modbus.html. Here is the front page of the web configurator, which shows the chassis model, serial number, UEIModbus version, and status of the slave service. On the left-hand side, we have the list of all the layers in the chassis. Let's look at configuring a board. The device parameters allow us to select the encoding type, which is useful to match the bit arrangement of your HMI or Modbus Master. For inputs, measurement type is selected through this drop-down menu. I have selected thermocouple inputs for my AI212 board. Change the gain to the highest value to measure the voltage accurately, and using the built-in CJC. If you have a Guardian feature board, such as the DIO449, you can simply enable the diagnostics here. The voltage and temperature of each channel is then placed into one of the Modbus registers for reading. To select the sampling rate for the layers, we go to the Timing tab. Here we can set the time local to the chassis and save it. And also set the scan rate. Checking this box will cause the Modbus slave to automatically start after power up. Once all the setup is complete, saving the configuration stores this configuration locally on the chassis. Now we can run our Modbus slave service. With the slave service running, we can view the values through any Modbus Master or HMI. I will be using Ignition by Inductive Automation to view and control the UEIModbus. To read and/or write to a Modbus slave, you must access one of the Modbus registers. Modbus has 4 registers. The coils register, used to read or write Boolean values, such as controlling a coil of a relay. Discrete inputs register, that contains read-only values of Booleans. Input registers, which are 16-bit wide registers for analog inputs. And holding registers, which are 16-bit wide registers used for analog inputs or analog outputs. 32 and 64-bit values are represented by combining several 16-bit registers. For simplicity, Modbus registers are printed in the web interface here. I've set up my HMI and Ignition to monitor a few of the inputs, as well as control the output voltage on one of my layers.
That covers the basics of UEI's implementation of Modbus. In just a few steps, any of our UEI products can quickly and easily be set up as a Modbus slave. If you have any questions about this or any of our other videos, give us a call, send us an email, or visit us online at www.ueidaq.com.